Our planet is being haunted. And no, this is not just a dramatic metaphor. There is something out there, in space, that has left astronomers puzzled for more than 60 years. Cosmic ghosts that dance in the shadows of our Earth-Moon system. Mysterious entities that challenge our capacity for detection and understanding. Imagine for a moment, gigantic structures up to 9 times larger than Earth itself, floating silently at specific points in space. Some scientists swear they have photographed these ethereal apparitions. Others, using the same equipment, find absolutely nothing. It's as if these cosmic entities play hide and seek with us, appearing to some and remaining invisible to others. Are we dealing with elaborate optical illusions, or is there something truly extraordinary hiding right under our noses? How can something be simultaneously so massive and so elusive? Is the moon really Earth's only companion in our journey around the sun? Today we will dive into one of the most fascinating mysteries of modern astronomy, the controversial ghost moons that may be silently accompanying our planet through the cosmos. Our ghostly story begins in 1961, when Polish astronomer Kazimierz Kordylewski made a discovery that would forever change our perception of the space around Earth. Through his telescope, he spotted 2 diffuse patches in the sky that looked like clouds but were located at very specific and suspicious positions, the L4 and L5 Lagrange points of the Earth-Moon system. But what the hell are these Lagrange points? Imagine space as a cosmic ocean, where the gravitational forces of 2 massive bodies, in our case, Earth and the Moon, create invisible whirlpools. These whirlpools are the Lagrange points, places where the gravity of both bodies balances perfectly with the centripetal force needed for smaller objects to move along with them. It's as if the universe had created natural cosmic parking lots, where asteroids, dust, and debris can park and remain relatively stable. These points were named in honor of the Italian-French mathematician Joseph-Louis Lagrange, who published an award-winning work on this phenomenon in 1772. In any 2-body system, there are 5 of these special points, labeled L1 to L5. 3 of them, L1, L2, and L3, are unstable, like balancing a ball on top of a hill. Small objects can be temporarily captured there, like the James Webb Telescope at L2, but they need to make constant corrections to avoid drifting away. But L4 and L5, these are different. These points form perfect equilateral triangles with Earth and the Moon, and are resistant to gravitational perturbations. That's why objects like asteroids and dust tend to accumulate in these areas, like leaves being blown into the corners of a garden by the wind. Kordylewski's discovery of these ghostly clouds at the L4 and L5 points, originally called libration clouds, but later known as Kordylewski dust clouds, ignited a scientific debate that continues to this day. Immediately after his observation, other astronomers, both professional and amateur, tried to locate these supposed clouds, but for years, no one else could find them. At the time, observation techniques were much less advanced than today. Many astronomers questioned whether these dust clouds were real or just optical illusions. After all, detecting such tenuous structures against the darkness of space was a challenging proposition. This skepticism persisted for years. From time to time, an astronomer would catch a glimpse of a dust cloud at one Lagrange point or another, and sometimes the clouds were visible at both locations. Some astronomers, including Kordylewski himself, managed to photograph the clouds, but for years, the dust clouds appeared so faint in photos that they could not be reproduced in newspapers. These photos were not like the photos we are used to. Images of these clouds had to be taken using photometric techniques, which involved glass photographic plates with long exposure times to capture the faint lights of distant celestial objects. In 1966,
NASA organized an aerial observation mission from their Convair 990 jet laboratory, operating away from city lights at an altitude of 39,370 feet. The astronomers on these 4 NASA flights managed to identify Kordylewski dust clouds at the L4 and L5 points, even photographing the cloud at L5. The orbiting Solar Observatory, OSO-6, also observed the clouds in 1966. However, in 1976, another astronomer named Siegfried Aruja at the Max Planck Institute for Astronomy used numerical simulations to show that conditions were unfavorable for dust to accumulate in the L4 area and questioned whether these clouds really existed. Most skeptics of the Kordylewski clouds believe that gravitational perturbation from the Sun, solar wind, and other planets have too strong a destabilizing effect on the L4 and L5 points for the clouds to be maintained. Additionally, radar studies of the clouds at that time produced negative results, leading many to believe that there was nothing substantial at the Lagrange points. These doubts were further reinforced in 1983, when observers using a 24-inch telescope near Tucson, Arizona, found no such clouds at L4 or L5. But then, just a few years later, in 1989, the clouds were photographed again by astronomer Winiarski from an astronomical observatory in the mountains of Poland. Winiarski observed that the clouds had several degrees of apparent diameter. These were also the first 3-color photometric observations of the clouds, and revealed that the clouds appeared much redder than the zodiacal light, which is sunlight scattered by general dust particles in space.
This observation suggested that the dust in the Kordylewski clouds is significantly different in composition from other local space dust, which raises the question, where are these apparitions coming from? But then, once again, the existence of the clouds was questioned when in 1991, the Japanese space probe Hiten made a loop around the L4 and L5 points in an attempt to detect dust particles, but failed to find any. However, astronomers say this should not be taken as evidence against the dust clouds, since Hiten only managed to make one loop around each Lagrange point. And if the clouds exist, the dust was probably moving too slowly to be detected by Hiten's dust detectors. As you can see, the scientific debate that began in 1961 after Kordylewski's initial observation continued through the decades. But now, scientists seem to have made a revolutionary discovery. In 2018 and 2019, astronomer Judith Slees-Balog and physicists Gabor Horvath and Andreas Barta managed to present clear evidence of the L5 cloud by examining how dust creates scattered polarized light patterns. To do this, they used a type of photography called polarized imaging, which uses a series of filters that can show light bouncing at specific angles. When light hits these dust particles, it scatters differently depending on the specific composition and arrangement of the particles, offering clues about the nature of the clouds. After collecting a series of images through various polarized filters, the scientists found that the polarized light patterns in the images matched theoretical predictions of what we would expect to see from sunlight scattered by dust clouds. More importantly, in their 2018 paper on the observations, they said that, in fact, these results meant that the scatterers could be nothing other than dust particles. To support these observations, they were able to better understand the formation of clouds at L5 through the use of computer simulations. They calculated the motion of 1.86 million dust particles to see how dust in that region of space could behave, and found that under the right conditions, this dust could become trapped at the L5 point and remain there for a very long time. So what's going on here? Why could some astronomers see these dust clouds and photograph them, while others claim they didn't exist? The answer may lie in the structures themselves.
despite extending for about 62,137 miles by 43,496 miles, almost 9 times wider than Earth. The total mass of the dust clouds is supposedly extremely small. Not to mention that the particles themselves probably have micron or submicron size, similar to the size of many bacterial cells. A micron is already a very small measurement, 1/1,000,000th of a meter. Individual particles of this size are visible only through a powerful microscope. The clouds are not only composed of these micron or submicron dust particles, sparsely scattered over a wide area and almost invisible to the naked eye, but recent models suggest that the shape of the L5 cloud also appears to be dynamic.
Models point to the structure being non-uniform, with the density of dust particles varying across the cloud and changing over time in sync with the Moon's orbital period. This could also support the idea that the clouds are not a stagnant accumulation of dust, but rather that they may be continuously losing and renewing their contents. It's like a constantly evolving dust storm rather than a fixed and stable cloud. Things like solar wind or gravitational attraction from the sun or other planets can disturb the delicate balance that keeps these dust clouds together, causing them to disperse before reforming again. This combination of extremely small particles dispersed over a large area, and the possibility that these clouds can form, disperse, and reform repeatedly over time, could help explain the discrepancy in observations over 3 decades. However, the tentative confirmation of the L5 cloud in 2018 still leaves open the scientific debate about whether these clouds exist continuously or appear and disappear depending on the influence of the sun and other planets. Many questions remain about the Kordylewski dust clouds, but one thing is certain: these observations are not just a mirage, but a real phenomenon within our Earth-Moon system. Even though aspects of their structure, evolution, and composition remain under investigation, there is broad acceptance that these clouds are worthy of further study. Although these so-called ghost moons that orbit the Lagrange points of the Earth-Moon system may seem supernatural, our planet is no stranger to additional moons. In fact, Earth has had several mini-moons and quasi-moons before, though very different from the Kordylewski clouds. To begin with, mini-moons typically come and go within a year, while the gravitational traps, or Lagrange points, which are theorized to cause these dust clouds, have existed since our Earth-Moon system formed, making the phenomenon potentially billions of years old. In my opinion, our planet's possible ghost moons are perhaps the most exciting of these obscure types of moons because of how unique they are. Despite being dynamic structures, these dust clouds are a long-term feature of our Earth-Moon system, and we still have much to learn about them. Observing these dust clouds has tested the limits of our observational abilities, and as our technology and science improve, so too can our understanding of the Kordylewski clouds. These ghostly dust clouds continue to haunt our skies, reminding us that even the faintest and most shadowy traces of cosmic apparitions can suggest something tangible and worth investigating. They represent a fascinating reminder that the universe still holds secrets right beside us, waiting to be discovered by curious minds and increasingly advanced technology.
The mystery of Earth's ghost moons teaches us that science is a continuous process of discovery, questioning, and rediscovery. Sometimes the truth is literally floating right in front of us, waiting only for the right tools and the correct perspective to be revealed.
If you were fascinated by this cosmic mystery as much as I was, don't forget to like this video to help me continue bringing content about the most intriguing secrets of the universe. And of course, subscribe to the channel so you don't miss any of our investigations into the most mysterious phenomena in the cosmos. I'm sure you'll love one of the videos that are appearing on your screen now. Click and embark on another incredible adventure through the cosmos. Thank you for following along until here, and until the next exploration through the mysteries of the universe.